Okay, so let's look at this question here, which was taken from the year 2022, paper 2, question 3. This is from the H2 A-level mathematics actual paper, all right? So the curve C is defined by this parametric equation of x equals to 3t squared plus 2. That's pretty okay. And y 6t minus 1, where t is bigger equals to negative 1. What we need to do now is essentially find the Cartesian equation of n. This is, the line n is a normal, okay, the line n is a normal to C at 14 to 11. So find the Cartesian equation of n. This is the normal, right? I'll give you an answer in this form. Okay, it's pretty okay. First thing is you try and just plot this graph using your GC. Try to make sense of how does it look like. I would suggest doing that. And also remember, just remember, a lot of times students forget about this, which is pretty important. So after they key in the value, that's what they say this is 3t squared plus 2, then this will be y will be 6t minus 1. And what you need to do is actually just zoom standard here and you get this graph. But please remember that what we're looking at here is anything bigger than a 6, right? So just go to window, y over 6, and maximum we just put this. Okay, this is fine because this is actually the graph that we're looking at. It's something like that. And we have 0.14, right? So not sure where is it at, but I'm gonna just roughly draw this out so that you understand. So it's from the graph we know it's like that. Okay, so this is C here. C is a normal line point. So the normal will be something like that. This is normal, 90 degrees, like that, right? So this is the line N. All right. So I'm just probably gonna draw this down. Right. So this case, C is actually 14, 11. Now, the thing about parametric equation is very important to know what this t corresponds to. Very, very important. So because before you even do that, you just need to know the parameter which corresponds to the point here. If not, it won't work. So I know that x is equals to 14 and also equals to 3t squared plus 2. And y equals to 11 also equals to 6t minus 1. So I'm just going to use 6t minus 1 because this is linear. 6t minus 1 equals to 11. So 6t equals to 12 and t equals to 2. So this case here, we know that t equals to 2. So what I'm going to do here is, I'm going to replace now. Always check your graph. So window setting, I'm going to put y min as maybe negative, y max as 15. And this as negative 1 here. Then y max probably I put as 15, probably. That will give us this graph here. He's not drawing the graph. He's draw it up. Graph. 0, 1, 6 to 10, right? Okay. So this is a graph we're looking at. So just trace, press trace and key in the parameter of 2 to give you the 0.11, 14, right? 14, 11. So this point here is important. This is important. Now, once you've done that, what we need to do next is actually just to find the gradient. This is dy dx. This is line n here. Okay, we need to find the gradient of this normal here. So we find dy dx first. Dy dx is actually dy. We need to find. So this is x and 3t squared plus 2. So dx dt will just be 6t, and y equals to 6t minus 1. So dy dt 6. So dy dx 6 over. So it's dy dx is just dy dt divided by dx dt. That will be 6 over 6t equals to 1 over t. All right. So that is it. You get that. Essentially, this is m tangent. Is dy dx equals to, when t equals to, what's t? T equals to 2 over 2. So m normal will just be negative 1 over half, which is negative 2. Okay, is m normal here. So this point at this juncture, once you get the m normal, should be quite straightforward already. So the equation of tangent of normal. Okay, we want the equation of normal, right? The equation of normal, Cartesian equation. Cartesian equation just means y equals mx plus c. So this would be y equals to y1 equals to m normal x minus x1. I prefer this equation here. So y would just be 11. M normal would be minus 2 here. And this is x minus 14. Right? There you go. Then once this is y equals to minus 2x plus 28 plus 11. This is y equals to minus 2x plus 39. But we won't need ax plus b. So this will be, just rearrange this, will be 2x plus y equals to 29. Alright, sorry, 39. So that's how you do this question here proficiently. So let's look at part 2. The area enclosed by CN and the x-axis. So C is this curve here, and the N and the x-axis here, right? So very clearly what we want is this area here. Now this looks like a very small graph. So let me just move on with, I just copied the graph from the, what do you call it? The, from the GC. So there goes, this is y equals to 60 minus 1. So what we now need now is actually, this is a tangent. Of course, this is not the line which we are interested in. We want this normal. Here, of course, we have the x-axis here. All right. And the thing now is we know that this point we are given is actually 14, 11. So it's very good to just put a t equals to 2 here. This is parameter. The parameter you're looking at is t equals to 2. And the graph is this, and this, right? And also the x-axis here. So what we're going to do is actually just find the area here, this triangle. We're going to add with this part, right? The area under this square plus this triangle. So I think that's the first thing you must be able to tell. Then the line here shouldn't be a problem. We already found this line here. This is line N, right? This is line N, where the equation here is actually just N. Equation here is just, what do you call it? This line N here. The equation is just 2x plus y equals to 39. So this is 14. So this part here, to find this shouldn't be too big of a problem. What we need is actually when y is 0, x is just 39 over 2. So this is 39 over 2. Now what is the problem is actually this point here. This we want find to find this to find it quickly. This is y equals 0, right? And the parametric form is 6t minus, so 6t minus 1 equals 0. And this will give you t equals to a 6. Actually, what you need is just t equals 1 over 6 here, which is the point which the point there which you need. But if you want to use find the x out as well, it's fine, but it's quite redundant actually. So this will be 3 over 36 plus 2, I believe. It's 25, 12. So this is 25 over 12 for the x-axis here. Okay. So you just let y 0 because it's the axis. Okay, so this is where it's 25, 12. So to write this formula, the required area, okay, what we need is this graph here, this half, sort of like a half a potato plus this triangle here. Okay, then we're gonna start off with integrating from 25 over 12, and it ends at 14 is y dx, plus it'll be half times base. The base here would be 39 minus 2 minus 14. So this is 39 minus 2, 39 over 2 minus 14. And the height would be 11, right? The height here is 11 units. So I'm going to just write this down. This is actually 11 units. Right. So the area of triangle is not an issue. Half times base times height. But what we need now is to change this to in the parametric form, which we have y is 60. So dx dt is actually 60 as well. So just remember dx is actually 60 dt. So this case here will be y is actually 60 minus 1. dx dt will just be 60 dt. Right? Now, take note, this is where a lot of students get confused. This is x equals to 14. When you change to dt, just remember to change the boundary. A lot of times students, I can foresee that a lot of students forget to write the corresponding t here. When x is 25 over 12, the parameter is 1 over 6. And when x is 14, the parameter is 2. So this is t equals to 2 here. So what we're going to do is actually just expand this out. So this will be 6. I'm going to just bring this to below. dt. I took the t out, and this will just be 29 over 2 minus 14 times 11 over 2. That will be 121 over 4. And this will give us plus 121 over 4. This will be 6 t cubed over 3. So this 2 minus t squared over 2. Okay, so I'm going to teach you a little trick to use your calculator to replace this value. So many students don't really know this. So what you do is just put 2t cubed. Okay, just 2t cubed. Okay, and after which we're going to put as minus t squared. So alpha. I'm going to use t as my my x, and 2. Okay, so now I'm going to put the value of 2 in. So what I'm going to do is I just press 2 storage x. Okay, that will be 2. Go up, and this will be 14. So this will be 6. 14. The other is the 6 x, and then this will be negative 216. I hope this is the answer. Just key in calculator, should be able to get answer there. There you go. So this would be 2057 over 18 units, square units. Alright, so I do this question here proficiently. Let's look at part 3. So let's look at part 3a. So the curve C and the line N are both transformed by a two-way stretch. Scale factor of 2 in the x direction and scale factor of 3 in the y direction. So the x direction and the y direction for C and N. Alright, so meaning to say they will just do a two-way stretch test to form the curve D and line M. Alright, find the enclosed area by D and M at the x-axis. So essentially, everything will be stretched in the same direction. So it's just a mark. So there's a faster way to do it instead of just finding the equations separately. So this is what I'll suggest. If you are not too sure how this is going to pan out, what we could do is actually just try and draw something. Okay, the shape will be the same, right? So for say if we have a triangle as such, and this is like a x unit and this is a y unit, right? And it say that we just follow the same exact same method. We have a two-way stretch, scale factor of 2 in the x direction, so it becomes 2x, and this becomes 3y value here. Okay, so in other words, this should be higher. This is much higher. I'm just gonna use this illustration, very quick short illustration here. So the area here will be half times base times height. The area here will be half times base times height, right? So this case here, if you were to do this same logic here, it's a very sort of like a very straightforward way. But if the ratio of the area would then be half to 3, and there'll be 1 to 6. Am I right? Okay. So similarly, what you have just done there is the new area, the area enclosed will just be 1 to 6. So I'm going to take the previous part, 18, multiply by 6. That will give us 2057 over 3, and this will be units square. Okay, so that's how you do this part quickly. Of course, you can use other methods to go and try and find it, but this is just an example. Uh, if you want to use the longer way, is also possible. So let's look at this part here. Now we need to find the Cartesian equation of D. This is obviously D is from C, right? C becomes curve D here. So we're gonna try and understand this part here. This is just transformation of graph. So part 3, C becomes D. Okay. We have C, which is actually x equals to 3t squared plus 2, and y equals to 6t minus 1. So to become D, we were told that what we need to do is just scale this x here, x, right? You have to scale factor a 2 in the x direction. So meaning to say, replace x with x over 2, right? If you scale factor of a 2, which is x over 2, so meaning to say this is x over 2 equals to 3t squared plus 2. Similar with this one over here. If we want, this will be replace y with y over 3. So this is y over 3 equals to 6t minus 1. So this would give us d will be x equals to 6t squared plus 4. Rather, this is x equals to 2 times 3t squared plus 2. And y equals to 6t minus 1. Of course, it's a Cartesian equation, right? We just need the Cartesian equation. We don't really need the... Yeah, we don't really need the boundary. Just need the Cartesian equation. So from here, what we can do is I just make t the subject. So from y, y is equals to 18t, or maybe I just put this as y over 3, 6t minus 1, so t is equals to y minus 3 plus 1 by 6. So I'm going to sub 1 into 2. Okay, there you go. Because you just want the Cartesian. Cartesian equation just means from the parametric form, get rid of the t. You need to get rid of the t, okay? Get rid of this, so x equals to 2. Because you do not want to have a parameter. Parametric means it contains parameter. Cartesian just means it doesn't contain any parameter. Okay, so there you go. This is one. King calculator. And I hope we get the answer there with x equals to 6. Maybe I just... 36. Okay, that will be... We need the... So I expanded this in. And this over here. In calculator. Okay. How do I have 54? Okay, so this is a Cartesian equation of D. So I'll do this question proficiently. If you have any questions at all, please let me know and I'll see you in the next question.